Hi everyone, this is Ms. Shea. In this video, I'm going to go over how to do molarity problems. Now before I get started, I would suggest that you print out the handout, or if you can't print it out, you can grab a piece of paper and just follow along with me as I'm doing these problems. I would also suggest that you have your periodic table in front of you and you also need a calculator. So go ahead and pause this video if you need to go grab those stuff, and I'll be waiting for you when you get back. So let's start by talking about what is molarity. Molarity is a unit of concentration. Now, concentration is a measurement of the amount of a solute that is in a given amount of a solvent or solution. Now remember, a solute is just the stuff that's being dissolved in a solution. So what we're looking at is how much stuff is dissolved into a solution. The more stuff that's dissolved, the more concentrated it is. Think of it like if you're making Kool-Aid. If you put a lot of the Kool-Aid powder into water, then it's a concentrated Kool-Aid solution. And in that case, the Kool-Aid probably tastes great. But if you put a small amount of Kool-Aid powder into the water, then you have a very diluted solution. So diluted just means not very concentrated. So you don't have a lot of solute, the Kool-Aid powder, in the solvent, the water. So that's a diluted solution and it's not going to taste great. Okay? Now, when we are talking about concentration in chemistry, the most important unit that we use is molarity. So molarity is abbreviated with a capital M. Do not use a lowercase m. Lowercase m usually is used for another concentration unit, molality, and that's not what we're talking about here. So molarity is capital M, and of course it's called molarity, so it has something to do with moles. Molarity is equal to the amount of solute in moles dissolved in a given volume of solution in liters. So when we look at a mathematical equation for molarity, molarity is equal to the moles of a solute divided by the liters of solution. So make sure that we pay attention to the units. The solute has to be in moles and the solution has to be in liters, right? And if they are not, then we need to convert them. So how do we do molarity problems? Well, first, you need to make sure that the solute's amount is in moles. So if you are given grams, then you have to convert it to moles. And you do that by dividing by the molar mass. Now, if the amount of solute that you are given is already in moles, then great, you can skip on to the next step. Step 2 says if you are given milliliters of the solution, you must convert it to liters. And you do that by dividing by the milliliters by 1,000. Now, if you are already given liters, then great, move on. Third step, use the formula to solve. Okay? All right, so let's actually do an example here. This example says, calculate the molarity of a solution prepared by dissolving 12.0 grams of KMnO4 in enough water to make 750.0 milliliters of solution. All right, so I'm going to look through this problem first and figure out what I'm given and what I'm looking for. So I am going to calculate the molarity. So I'm looking for the molarity, big M. And I'm given 12 grams of KMnO4. So KMnO4 is the solute. Now notice we're given grams, so I need to convert that to moles. And it says also 750.0 milliliters of solution. So that's our volume of solution, but that is in milliliters, so I need to convert that to liters. So I can already tell that I'm going to have to follow all 3 steps. Okay, so the first step is to convert the 12 grams of KMnO4 to moles. So I'm going to do this real quick right here. 12.0 grams KMnO4. KMnO4, and I'm going to need the GFM of KMnO4 to convert. And I'm going to do that real quick down here. So I have 1K, and K has a mass of 39.098. I have Mn, and Mn has a mass of 54.938. Do not confuse Mn with Mg. I find that a lot of students tend to do that. And then there are 4 O's. And O has a mass of 15.999. And when you add all those up, you get 158.032. So this means there's 158.032 grams in 1 mole. All right? And so when we get back to the grid, we're going to put 158.032 grams on the bottom so that I can cancel out grams. Okay, I'm going to put 1 mole on the top. Okay, so grams cancel. And I'm going to divide 12 divided by 158.032, and we got 0.0759 moles. Okay, so that is the first step. I have now converted the grams of the solute to moles. Okay, the next step that I'm going to have to do is to convert the milliliters to liters. So I need to take the 750 milliliters for the solution, and we're going to divide by 1,000. Now, why do we divide by 1,000? Well, it's because 1 liter is equal to 1,000 milliliters. Okay, so we're going to put 1,000 milliliters on the bottom and 1 liter on the top, and so milliliters can cancel out. And so we'll take 750 divided by 1,000, and we'll get 0.7500 liters. All right, so now I have moles of the solute, 0.0759, and liters of solution is 0.7500. And so now I just need to plug these two numbers in to the molarity equation. So the molarity is equal to 0.0759 moles divided by 0.7500 liters. All right, go ahead and put that into your calculator. And we're going to round to 3 sig figs because that's the least number of sig figs we have in the problem. And I got 0.101 molar. So usually what we would do is we would write the big M for the molarity as a unit. Okay, and the way that we read that is molar. So the answer is 0.101 molar. Now what this really means is there is 0.101 moles of the solute of KMnO4 in a liter of the solution. Okay, I'll do one more with you. Let's look at number 1 here in the practice problems. Calculate the molarity of a solution prepared by dissolving 20.0 grams of NaCl dissolved in enough water to make 1.0 liter of solution. So again, I'm going to go through and just look at what I'm given. I need to find molarity, so I'm looking for M. I'm given 20.0 grams of NaCl. Now this is in grams, so I'm going to need to convert that to moles. And I'm given 1.0 liter of solution. And that's already in liters, so great. I don't need to convert to liters in this case. All right, so I'm going to start by converting the 20 grams of NaCl to moles. Okay, so I'm going to write that out and draw the dimensional analysis grid. And I'm going to need the GFM. For Na, the mass is 22.990, and for Cl, that's 35.45. And that adds up to 58.44. So 58.44 grams in 1 mole, and we'll put 58.44 on the bottom so that grams can cancel out, and 1 mole is on the top. Okay, and let's put this in a calculator, and I got 0.342 moles. All right, and since I don't have to convert the liters, I'm just going to plug into the equation. So the molarity is equal to the moles of the solute, 0.342 moles, divided by the liters of solution, 1 liter. And that will be equal to 0.342 molar. And that is your answer for number 1. All right, I want you to pause this video and go ahead and do number 2 and number 3. When you're done, come back and I'll reveal the answer to you so you can see if you've done it right. All right, so let's check your answers. For number 2, you were supposed to have converted the 3.5 grams of calcium hydroxide into moles, and you should have gotten 0.047 moles. And then you were supposed to convert 100 milliliters of the solution into liters by dividing by 1,000. So that would be 0.1000 liters. And then plug them into the molarity formula. So 0.047 moles divided by 0.1000 liter, and you get 0.47 molar. For number 3, you're supposed to convert 0.25 grams of PbNO32 into moles, and you should have gotten 0.00075 moles. Now, if you use scientific notation, that would be 7.5 times 10 to the negative 4 moles. And 500 milliliters need to be converted to liters. So if we divide by 1,000, we would get 0.5000 liters. Okay, and then you divide 0.00075 moles by 0.5000 liters, and you should get 0.0015 molar. Now, if you had used scientific notation for that answer, it would be 1.5 times 10 to the negative 3 molar. So now that we are familiar with the basic molarity problems, let's go ahead and look at how we do some slightly more complicated molarity problems. In these types of problems, you are not going to be looking for molarity, but you're looking for either the amount of the solute or you're actually looking for the volume of the solution. So if you are asked for moles of the solute, then we would rearrange the original formula so that we are looking for the moles of the solute. So the formula becomes moles of solute equals molarity times liters of solution. If you are asked for the liters of the solution, then you would rearrange the formula so that liters of solution is equal to the moles of the solute divided by molarity. Now, make sure that you are still converting grams into moles and milliliters into liters when you're using these formulas. So let's look at how this works. Let's do a couple examples. All right, so first example says, calculate the moles of NaCl needed to prepare 175 milliliters of 0.500 molar saline solution. All right, we're going to first figure out what we're looking for. So we're looking for the moles of NaCl. So we're looking for the moles of the solute, and we are given 175 milliliters, that's the volume, and 0.500 molar, so we are given the molarity. Now, notice that the volume unit is milliliters, so I'm going to need that to be converted to liters. So I'm going to do that first. All right, and remember that we do that by dividing by 1,000. So 175 milliliters divide by 1,000, 1,000 milliliters in 1 liter. And that will give me 0.175 liters. Now that we have that, then we can put that into the formula, the rearranged formula. So the moles of the solute is equal to the molarity, 0.500 molar, times liters of solution, 0.175 liters. So the answer is 0.0875 moles. So notice we are looking for moles in this case, and that is why moles will be the answer. Now remember, molarity really is moles per liter. So the liters have canceled out, and that's why the answer unit ends up being moles. Let's look at our next example. It says, calculate the liters of 2.5 molar NaOH solution that can be made with 31.52 moles of NaOH. Okay, so let's look at what we are looking for. We're looking for liters. Okay, that is pretty clear. All right, and I am given the molarity, 2.5 molar, and I'm also given the moles of the solute, 31.52 moles. Okay, so it looks like we already have moles of the solute. I don't need to convert that. Great, just plug it into the formula. So the liters of the solution is equal to the moles of the solute, 31.52 moles, divided by the molarity, 2.5 molar. And the answer is 12.608. We'll round that to 2 sig figs because that's the least number of sig figs in the problem. And that would be 13 liters. Let's try a couple more, and then I'm going to ask you to pause the video so you can do a few by yourself also. So I'm going to do number 1 and 2 with you, and then I'll have you guys do number 3 and 4 by yourself. So number 1, what is the volume in liters of a 0.200 molar solution made with 6.00 moles of LiF? Okay, so we're looking for the volume of the solution in liters. We are given 0.200 molar and 6.00 moles. Okay. Looks like I don't need to convert anything here. So all I need to do is plug this into that equation. So the liters of solution is equal to the moles of the solute, 6.00 moles, divided by the molarity, 0.200 molar. Right? Plug that into your calculator, and the answer is 30. All right, and I need 3 sig figs, so I'm going to do 30.0, and the answer is liters. 30.0 liters. There we go. Number 2, how many moles of CaCl2 would be used to make 300.0 milliliters of a 5.0 molar solution? So we're looking for the moles of the solute, and we are given 300.0 milliliters, so we need to convert milliliters to liters, and we're also given 5.0 molar, that's our molarity. So the first thing I'm going to do is convert the milliliters to liters. 300.0 milliliters divide by 1,000, and that is equal to 0.3000 liters. And now that we have done that, we can plug it into the equation. Now in this case, since we're looking for moles, then we're going to use the equation moles of the solute is equal to the molarity times the volume times the liters of solution. So the molarity is 5.0 molar, and we're going to times the liters of solution, 0.3000 liters. All right, put that into the calculator, and we get 1.5, and that's perfect because we want 2 sig figs. And the unit here is going to be moles. And that's our final answer for this one. Okay, so go ahead and pause the video, and I want you to do number 3 and 4. When you are done, come back. You can then check if you got those answers correct. All right, so for number 3, we are given the liters of the solution and the molarity, and we are looking for moles. So there's nothing to convert here. All we need to do is plug it into the equation. So the equation is the moles of the solute is equal to the molarity times liters of solution. So we'll take 3.5 molar multiplied by 2.50 liters, and you will get 8.8 moles. Now I rounded that from 8.75, which was the answer that was in the calculator. And the reason I rounded it to 8.8 is because if we look at the givens that are in the problem, you'll see that 3.5 has 2 sig figs. So we are going to round the answer to 2 sig figs. And in number 4, we are looking for the liters of the solution, and we are given molarity and moles. So we're going to use the liters of solution is equal to the moles of the solute divided by the molarity equation. In this case, we do not need to convert anything, and so we just plug it into the equation. So 31.52 moles divided by 12.5 molar, and this time we're rounding to 3 sig figs in our answer, so the answer is 2.52 liters.